Perfect. If you guys are looking at yesterday's notes and you're looking at today's notes, the title is exactly the same. So we're doing 7-2, and it's, again, we're looking at inverse sine, inverse cosine, and inverse tangent, and the buddies today. Okay, so it's like continued. So this is an extension of what we learned yesterday. So as we're going through, we're going to talk about the buddies now. So as we take a look, some of the buddies that we should be aware of, I call them the buddies, the inverse, the reciprocals, secant. Secant is whose buddy? Is cosine. So he's going to work in the same quadrant as cosine. That's from 0 to pi over 2. Let me get my little fancy highlighter here. So again, I'm talking about inverse secant that works from 0 to pi, which is 180 degrees. So if I'm looking here, 0's right here, pi's right here. So it's going to work in these two quadrants. Okay. And if I'm have a positive ratio of sides, it's going to be working in quadrant 1 like everybody does. And then if it's in quadrant 2, it's because it's a negative ratio of sides. And then again, we talked about yesterday, reminder, if I'm in Q2, then that's obtuse. That's angle is greater than 90 degrees. So it's going to be 120, 135, 150. Okay, it's going to be a big angle. So be aware of that. Okay. So right now, the ones that work in quadrant 1 and 2 are inverse cosine and inverse secant. All right. So now we move on over to inverse cosecant. And cosecant's buddy is sine, and inverse cosecant works in the same quadrants as inverse sine. It works from negative pi over 2 to pi over 2. Again, that's negative 90 to 90 degrees. So visually, what's going on? 90 degrees is up here. That's pi over 2. Negative pi over 2 is down here. So it works in these two quadrants, 1 and 4. And again, if it's a positive ratio of sides, then it's going to be working in quadrant 1. And if it's a negative ratio of sides, like negative 2 over 1 or what have you, then we're going to be in quadrant 4. Just a reminder, anything in quadrant 4 is going to be a negative angle, so it's going to be negative 30, negative 60, negative 45 degrees. Okay, so be aware of that. And again, final answers are always in radians, so we're going to have to convert those. Okay, so right now, there are 3 trig functions that work in quadrant 4. Inverse sine, inverse cosecant, and we talked about yesterday, inverse tangent. So those are the 3 that work in here. And last but not least, we have inverse cotangent. And this guy works from 0 to pi, or 180. So add inverse cotangent over here to that list. Okay, so there are 2 groups. 3 of them work in quadrants 1 and 2, and 3 of them work in quadrants 1 and 4. Okay, so far so good. All right, so we'll see the buddies from time to time as we're working through. You guys have any questions on those? We're okay with that? All right, so let's get working here. What we're going to start seeing now is trig functions like sine, cosine, tangent, and inside of those are going to be the angle, and it's going to be in the form of an inverse trig function. So in this case, we have the cosine of the inverse sine of root 2 over 2. And you look at that and you're like, oh my gosh, what in the heck am I finding here? So it's always nice to know right away, what am I finding? And it's based on the trig function that's on the outside. So if you guys take a look, back in chapter 6, I asked you, hey, what's the cosine of 30 degrees? And you guys gave me a ratio of sides of a over h, okay? So if you see a regular trig function on the outside, that tells you what you're finding. Again, we're looking for sides here, okay? Specifically, cosine is ka. So ka, toa, we're going to be finding a over h. Okay? Now, to find that to find those ratio of sides, I'm going to go ahead and cover up cosine, and I'm going to figure out what in the world is the inverse sine of root 2 over 2. I'm going to draw that triangle so I can figure out what A over H is. Okay, so go back. Inverse sine is what we learned yesterday in 7-1. It's a positive ratio, root 2 over 2. So I'm going to draw it in quadrant number 1. Okay, reminder sine is O over H. So this is O, that's H. So this guy is root 2, and the hypotenuse is 2. Okay. Well, I want cosine, so I'm going to have to figure out what this angle is, which is going to help me figure out what this side is. If you don't know what this angle is, that's okay. You can just use a little Pythagoras, a squared plus b squared equals c squared, to figure this out. And we all know what this side is, right? What's this side of a 45, 45, 90? Root 2, yeah, boom. All right. All right, so we know this is a 45-degree angle. It's a 45, 45, 90. And we know the inverse sine of root 2 over 2 is 45 degrees. If you want to convert that into radians, you can, but you don't really have to. Because we want to know what is the cosine of that angle. We want to know what's the cosine of 45 degrees. I'm going to take that 45 and just plug it in right for this guy right here. All right. And if you guys are at home and you have questions, let me know what I'm talking about here. So cosine of 45, we did this back in chapter 6, right? Cosine is ca, A over H. And I have my triangle all set up. What's A? And what's H? Root 2. And my hypotenuse is 2. That's my ratio of sides. That's what we're looking for. Final answer is root 2 over 2. Okay. You guys have any questions with that one? Okay. Lorelai? You don't really need to know the angle. You just want to know what this is a great question. You just need to know what's the adjacent over hypotenuse of that angle. Okay, so if you didn't know that was 45, it really doesn't matter. And we're actually going to see that on example, what is that, number 5. You don't really going to find that angle at all. You're just going to want to know what the cotangent of that angle is. Okay, so that's a great question. Do I need to know that angle? No. If I know to find that third side using Pythagorean theorem, or you know your reference triangles, then we're good to go. It's a good question. All right, any questions on that one? Fantastic. All right, ladies and gentlemen, as we take a look at example 2, first thing I want to know is what the heck am I finding, Mr. Gotsch? So I have the cotangent, regular cotangent of the inverse sine of -1/2. So this guy tells me everything I'm looking for. Regular cotangent from chapter 6. I said, hey, what's the cotangent of 30? And you gave me sides or angles. Cotangent of 30 degrees. It's going to give you sides, specifically AO, A over O. Okay. All right, so inverse sine, I got -1/2. I'm going to work inside out, so I cover this guy up. Now, I'm a visual person, so I like drawing these triangles. I think that helps you guys visualize what's going on. I don't know what this angle is. Honestly, I don't really care. I just want the A over O of that angle. Okay, so I'm going to go ahead and draw this guy. Inverse sine works in 2 quadrants, 1 and 4. And this is a -1/2. So I'm going to draw this thing in 4. Make a 90 with the x-axis. Remember, sine is O over H. So I got O across from this angle here. That's -1. I got H. Now I can find the adjacent leg using Pythagoras. Or I should know what reference triangle this thing is. Right? What's this angle here if that's across from 1? Is that 30 or 60? 30. That's 30, and then this guy's the 60. So that means this is root 3. Okay, so again, you can do Pythags. You don't really need to know those angles, Lorelei. You just need to know what's the adjacent over opposite of that triangle. So you might just use Pythagorean theorem to figure that out, or know your reference triangles. Okay, so sine of -1, inverse sine of -1/2 is this angle, 30 degrees, which is in this case -30 because it's going down. And that's basically what I want to do is I want to figure out what is the cotangent of -30. What is A over O? Well, what's A of this angle? √3. And then O is what, -1? So final answer, I'd probably simplify that to -√3. Final answer. Okay, so again, I got my ratio of sides. I got A over O, which simplifies to -√3. So it's not too bad. This is kind of mixing, you know, chapter 6 stuff in with chapter 7.1 stuff. Okay. And that's pretty much what we got in examples 3 and 4, but now they're flip-flopping. Okay. So if you look at examples 3 and example 4, now we have the inverse trig function. Right? We got inverse cosine of the cosine of -π/3. Okay. Yesterday in chapter 7.1, we said, well, the inverse cosine of the cosine of -π/3 is -π/3 if that falls in between 0 and pi. That takes us back to this part here. Inverse cosine of the cosine of u is u if u is between 0 and 180. Right? 0 and pi. But I got -π/3. That's -60. Is -60 between 0 and 180? No. So I can't say my answer is -π/3. I wish I could, but that means we're going to have to do some work here on this problem. Okay? So what are we looking for, Mr. Gotch? This tells me everything. If I'm using inverse cosine on my calculator, yesterday we did this. This is getting me to find angles. And that angle needs to be in radians. So again, if I have an inverse trig function, we are finding angles when I'm all done. Okay? So I'm going to cover this guy up, and I'm going to figure out what is the cosine of -π/3. I'm trying to figure out what is A over H of that angle. Okay? Well, again, -π/3 is -60 degrees. If you need to, multiply by 180 over pi. The pi's cancel. 180 over 3 reduces to -60 degrees. There's a negative in front. So I'm going to go ahead and draw that guy. Okay. Now this is regular cosine. Regular cosine works in all 4 quadrants. This is not inverse cosine. So this is regular cosine. This is a chapter 6 question. I asked you, hey, what's the cosine of -60 degrees? You gave me what A over H was. So I'm going to draw this in quadrant 4. Again, this is regular cosine. So this is a -60 degree angle. And we want A over H of that angle, right? So what's across from 60? Bigger. √3. In this case, that's negative. That means this has got to be 30. So that guy's the 1. And then the hypotenuse is 2. So remember, across the smaller angle is the smaller side. 30 is across from 1. 60 is across from √3. Because √3 is a little bit bigger than 1, just like 60 is a little bit bigger than 30. Okay. Well, what's A and H from this angle here? What's A over H? Here's my angle. Here's H. Which one's A? 1, right? This guy's A. So we end up with 1/2. So basically what I'm going to do now is I'm going to take that. I'm going to plug it in right here. The real question is, hey, what is the inverse cosine of that ratio of 1/2? And now that's a chapter 7-1 question that we asked you to answer yesterday. Okay. Now inverse cosine works in 2 quadrants, 1 and 2. Because it's a positive ratio, I'm going to put this in the correct quadrant now, which is in quadrant number 1. And now that's going to put my answer between 0 and 180 degrees, or 0 and pi. So again, they gave me A, they gave me H, they gave me from this angle is 1, that's 2, which means I know what this guy is, either using Pythagoras or know your reference triangles. What is this guy? Root 3. So that means I got to know this angle. That's across from root 3, that's 60 degrees. So my angle that's across from that one is 60 degrees, which simplifies to what? Pi over 3. Okay, again, if you need to, you can do one of 2 things. You can look back at your chapter 6.2 notes. If I look at my 6.2 notes, we got our pinwheel. You should know our 60-degree angle is pi over 3. Okay, or you do a little converting. Divide by 180, put a pi on top. I always remember, now I don't want to be a cool guy here or anything, but I know these things by heart, as I've been doing this for so long, right? I always remember if it's got a 6 for the degrees, then it's going to have a 3 for the radians. Always the opposite. So if it's pi over 6, then it's 30 degrees. If it's pi over 3, then it's 60 degrees. Okay. So boom, pi over 3. All right. Do you guys have any questions with that one? Seems super scary, but not too bad. Let's take a look at one more. I got the inverse tangent of the tangent of 2 pi over 3. All right, so again, this tells me what I'm finding. I have an inverse tangent on the outside. I'm looking for angles. And again, we want it in terms of radians. If it's a regular trig function like 1 and 2, it's sides. If it's inverses, angles. Okay, so I work inside out. I cover this guy up, and I want to figure out what is the tangent of 2 pi over 3. What is O over A? Now for me, I like to convert those into radians to degrees. So what's 2 pi over 3, y'all? What is that? 2 pi over 3. 120. Okay, so I'm going to go ahead and draw that 120-degree angle. That's going to be put me in the quadrant 2. Remember, this is regular tangent, so regular tangent works in all 4 quadrants. So 120 is right here. Drop it like it's hot. To the x-axis, make that 90. And now the most important angle you come up with is this guy right here. That's your little reference angle. If that's 120 and the whole thing's 180, what's this guy? 60. Again, just subtract from 180. It's a linear pair, supplementary. We learned that in geometry. Across from 60, we know is root 3. So that means that's 30. So across from 30 is 1, and the hypotenuse is 2. Just don't forget, anytime I'm in the second quadrant, I'm going left 1, that's negative. And then up root 3, that root 3 is still positive. So far, so good with my reference triangle. All right, what's O? What's A? Opposite from that angle. What's this guy? What's opposite? Root 3 is opposite, so that means this one's adjacent. So I get root 3 over negative 1. So basically, I have the tangent of 2 pi over 3. I can take that and plug it in. So the real question now is, what is the inverse tangent of that ratio, root 3 over negative 1? Okay, now this is going to put me in the correct quadrant, right? So this is going to put me in what quadrant for inverse tangent? Inverse tangent works in 1 or 4, so I'm going to draw this thing in what quadrant? And it's negative and then 4. Making sense? Not making sense. So my angle should be between 0 and negative 90 degrees. Okay. So again, tangent is O over A. So I have opposite is root 3, and I have adjacent is 1. Technically, this one's going down, so I'm going to make that one the negative now. And then the hypotenuse is 2. And now I can find this reference angle. What's that guy? What's across from root 3's? 60. So again, I'm going to say my final answer is 60 degrees. I convert that to radians. That's pi over 3. Now, if I type in pi over 3, my math lab is going to say, wrong. Why is this thing wrong? It's going down, right? No hashtag Kesha here. No timber here. You guys don't think that's funny. I need new material, Mr. Gotsch. So final answer, that's negative 60 degrees. It's going down. Okay, that's a negative angle when it's going clockwise. That's negative pi over 3. Okay, and now that takes care of this part. Inverse tangent of the tangent of u is u only if u is between negative 90 and 90. Okay, this guy here, 120 was not between 90 or negative 90. So I had to do some work. I had to do, basically this is a two-step problem when you see these inverse sines and inverse trig functions on the outside. Okay, so big idea, regular trig functions, sides on the outside. Inverse trig functions, angles. All right, so let's flip this on over. Let's do a few more here together. And then I got some calculator tricks for you, and it'll be time to go. Oh boy, here we go. What in the world, Mr. Gotsch, are we finding? I have tangent of the inverse cosine of 1/3. I have regular tan. Regular tan. What are we looking for? Sides or angles? What did you say? Sides. Yeah. Specifically, tangent is TOA, O over A. Perfect. So I cover this guy up, and I'm working with inverse cosine of 1/3. Okay. Now this goes back to what Lorelei is asking. Hey, are you gonna? Do you really need to know the angle? And in this case, no, because I don't know like what this ratio of sides is going to give me. I have no idea. I don't know what the angle is going to be. I know what 1/2 gives me, but I have no idea what 1/3 is going to give me. So basically, I'm just going to go through and make my little reference triangle in quadrant 1 because it's positive. This is A and this is H. Okay, so A is right here. H is right there. So I have 1 and 3. But I want tangent of this angle, right? I want tangent of what we'll call it theta. I want opposite over adjacent. Well, the idea is they gave me adjacent is 1. I just don't know what opposite is. So I need to figure out what this guy right here is. All right. And how do you do that? Because this is not a reference angle, reference triangle that we use. So the only way to find that third side is to do what? Roll Pythagoras. So this is where I would set up a squared plus b squared equals c squared. So I would do 1 squared plus, we'll call it b squared, equals 3 squared. And this is 1, that's b squared, and that's 9. And I subtract over, and I end up with b squared is equal to 8. And then we square root that, right? Now I would probably simplify that, break it down 4 and 2, 2 and 2. You guys okay with me writing 2 root 2? Break it down in factor trees, 4, 2, 2, 2. Get a pair of 2s, those come outside, and there's a 2 left on the inside. Are you guys okay with that? Now I have my opposite. So I end up with my opposite is 2 root 2, and my adjacent leg is still 1. So final answer, I'd probably just type in 2 root 2 for my answer. Okay. So some of you guys are very smart and like, well, I don't really need a reference triangle for this one because they gave me 2 sides and I just need that third side. That's fine, but just make sure you know what you're doing. And I would prefer, especially on reviews and stuff, that you guys do these reference triangles. Okay. Any questions? All right, let's do one more that looks like this, and we'll do some easy ones. 7 and 8's easy, won't take very long. Cosine. Number 6, I want cosine of the inverse sine of negative root 2 over 3. Well, again, this tells me everything I need to find. Regular cosine is sides. Specifically, A over H. Okay, well, here's the idea. I don't know this reference triangle. I don't know where O is a root 2 negative, and then H is a 3. I don't know that. And I don't really care what that angle is going to be. I just want to know the cosine of that angle. So I'm going to go ahead and figure out, okay, I got inverse sine negative root 2 over 3. Again, this is O and H. I'm going to draw that guy in quadrant 4 because it's negative. Inverse sine. And I got O and I got H. And then we're going to call that theta. I don't know what this is, so give that 3. That's a negative root 2. What I need to know is what's cosine of theta. That's the big thing. I want the cosine of that angle, whatever that thing is. I want A over H. Right now, I know which one, A or H. I know H is 3. I just don't know A. So this is really just a Pythagorean theorem problem, if you know what you're doing. Okay, so set up Pythags. We'll call that A there. So I got A squared plus that negative root 2 squared equals 3 squared. That's A squared plus root 2 squared, negative or positive, still 2. That's 9. I'm going to subtract the 2 over. So I get A squared is equal to 7, and I get the square root of 7. You guys okay with that? So now I have my A, and now I have my H. I should get the square root of 7 over 3. Again, you don't care what that angle is. Okay, you just want to know what the cosine of that angle is. They're giving you 2 sides. You have to find the third side so you can set up. Okay? You guys have any questions with that? We're okay. All right, 7 and 8, we pretty much talked about cotangent with tangent yesterday, but let's see this again. Do we need to, am I going too fast here? Give you another second to copy that down here. All right, so when we're taking a look at number 7, I got inverse cotangent of 1. Okay, remember what cotangent is. Remember what I'm trying to find. It's a regular trig function. So again, we're looking for angles. This is like what we did yesterday. Okay, remember what cotangent represents. That represents A over O. So that 1 is an A over O ratio. Well, where does A and O completely reduce? Because they're exactly the same. 45, 45, 90. So again, when you see inverse tangent, we talked about this yesterday, and inverse cotan, and you see 1 or negative 1, so plus or minus 1, I want you thinking 45, 45, 90s. Okay? So the idea is this is really the cotangent of root 2 over root 2. And we know that guy is in quadrant 1. This is root 2. That's root 2. And we should know what this angle is. What's this angle? How many degrees? What's across from root 2's? 45. That's a 45, 45, 90. So we know this is 45 degrees. If you typed it in my math lab, it's wrong. We got to convert it to pi over 4. Okay. So again, this is a root 2, 2 for me. All right, so when you're doing example 8, again, we're looking for angles. I'm thinking this is root 2 over 1 when I see something like this. Okay. Well, this is H and this is O. I normally see root 2's as my opposite leg, not my hypotenuse. So what do you think they did here when they have H over O? They rationalize it so we can unrationalize. So we can unrationalize this guy. So again, if I have root 2 over 1, I can multiply by root 2 over root 2. And now this is, for us, the inverse cosecant of 2 over root 2, where that's H and that's O. Well, that would be drawn in this quadrant, quadrant 1. I don't need to redraw it, so I'm just going to show the angle over here. So I would get 45 degrees again, pi over 4. Okay, so if you just see a root 2 for inverse cosecant or inverse secant, again, I want you thinking 45, 45, 90 triangles. Okay. Last but not least, before we get out of here, example 9 and 10 says use a calculator to find the value of each expression rounded to 2 decimal places. When you look at your calculator, guys, the buddies, inverse secant, inverse cosecant, inverse cotangent, are not on there. So what we need to do is convert this thing in terms of the buddies, sine, cosine, and tangent. Okay? So here's the idea. If I have inverse cosecant, that is a ratio of sides of H over A. Well, who's his buddy? Cosine. Well, this would give you the same angle, A over H. So what I want you to do is take this and rewrite it so that it's the inverse cosine of, take this negative 3 over 1 and flip it so it's negative 1 over 3. And that's where number 1 being radians, so put your calc in radians and then let's plug it in. So if I have a calculator, I press mode, I go down to radians, okay, and now I just do second cosine of negative 1 divided by 3, press enter, boom, I get 1.91. Again, that's in rads, radians. Okay, if you're doing this and you're getting something that's bigger, like something between 0 and 90 degrees, or 0 and 180, if you do the inverse cosine of negative 1 divided by 3, and you get a big number, in this case, an obtuse angle, you're in degrees. Usually they want you in radians unless they say otherwise. Okay? So if I'm doing inverse cotangent, which is A over O, I need to convert it to inverse tan of O over A. So this is root 7 over 1. I would change this guy to inverse tangent of 1 over root 7. You don't need to rationalize that. Okay. All right, so if you're doing example 10, and I'm doing the inverse tangent of root 7 over 1, flip that as 1 over root 7, and I'm going to plug that in. So again, make sure you're in radians. Okay, and I'm going to do inverse tangent of 1 divided by the square root of 7. Okay, as I press that, I should get 0.36. Okay, make sure you're in radians as you're doing that. If you have any questions, please feel free to stop in. You guys have a great day.